In the previous video, I showed my emulation application running on the Windows and Linux and comparing the speed of actually running them on both using the SDL libraries. I didn't show it running on a Mac at the time because my Mac I tend to use for 3D printing only. I didn't want to go through all the hassle of updating it because it's a 2014 Mac and I haven't sort of done the updates really in the time that I've had it. But I did have to go through updates just recently because I'm working on actually getting all my daily work done on the Raspberry Pi 5 rather than an Intel PC laptop. So I've had to update my Mac because I've done filament printing on my Mac previously, which is these applications here. I've run these applications on the Mac because they don't actually have one which runs under Linux. This is the DaVinci 3D filament printer that I've got. But just recently, because I'm moving to hopefully running most of my day stuff on a Raspberry Pi 5, there's also the other 3D printing stuff that I do, which is to do with resin printing, and that uses a different slicer that I have to use to actually produce the files that I need for the 3D printer, and that I use Jitterbox, which is here, and that does have one which runs under Ubuntu Linux on an Intel processor, but unfortunately I don't have one which runs on an ARM processor, which is what the Raspberry Pi 5 is. So I've had to update all my stuff to actually run this on the Apple Mac that I have. But that's quite a good thing anyway, because I do all my other 3D printing stuff on this Apple Mac. So, and that's really all I use the Apple Mac for. So because I've had to go through all the process of updating the operating system, everything to the biggest operating system it could actually run on, I thought, okay, well, might as well install the SDL libraries on here. So when you install the SDL libraries, you just drag them into a file, a directory called frameworks on the hard disk. And that's the only thing you have to do to actually install the SDL libraries. There's no other stuff that you have to do. And then my make file for my actual application, because I've got these options here to actually make for a Linux operating system or the Windows operating system, I've just added one for making for the Apple operating system, and hopefully I should be able to find on that. Or actually, the only thing it needs to do on the actual make file is down here, where I compare for which operating system I'm using, and these are just the GCC command line arguments for the actual whichever operating system I'm using, because they just change, and then the build works fine on whichever operating system after I've just changed these things, because I don't actually have to change the source code at all. And I just had to add a -w because it tends to put out a lot of warnings on the Apple GCC. It must be a lot more sensitive for warnings, so I just suppressed those so I don't see them, because I'm not actually developing on the Apple system, so that's fine if I get loads of warnings here. And then you just have to add the frameworks and which framework you're using. So then when I come to do an actual build, if I do a make clean and then a make, and it'll go through and it actually does the actual build. And apart from putting out lots of warnings which I've suppressed, it actually builds pretty cleanly on the Mac. There's these warnings which I think to do with the linker, but they don't seem to affect anything. And then it'll go through and make all of the emulations and emulators, I should say, and they all seem to run fine on the Apple Mac as well. So after it's built these, which it builds quite quickly, if I go into the run directory and run one of the emulators. So when it comes up, I'll get these funny lines across it. I think that's to do with the timings of when I'm initializing the SDL environment. But apart from that, they run cleanly. So it all works fine. I also did a comparison with the timings, which I will go through. I'll update the timings part of the video and add this Apple Macintosh display to see how it compares with running against the Intel processor and Linux, and the ARM processor with Linux, and Windows 8 as well in the virtualization environment. So doing a comparison of the software running on different systems again, but this time with the Mac OSX included. So the top left is a Raspberry Pi with an ARM processor. Bottom left is Intel i3 on Ubuntu, and bottom right is Intel i5 on Ubuntu. Then the top right is Windows 8 running under Oracle virtualization on Intel i5, and then the top middle is Mac OS, and that's running on Intel i5 as well. And it actually runs slightly slower than the Linux systems, but it runs a bit faster than the Windows 8 on Oracle virtualization, which I think is actually slowed down a bit by the Oracle virtualization itself as well. But the actual Mac one will finish slightly after the Intel ones and the ARM processor ones. So there's the Intel ARM processor ones virtually at the same time. Then there's the Mac OS one running slightly a bit slower, and then finally the Windows 8 on Oracle virtualization is about to finish any second now.